Welcome to the Trend Detection Podcast, powered by Siemens. And now your host, Niall Sullivan.
Hello, and welcome to the latest episode of the Trend Detection Podcast. I'm really pleased to be joined by an external guest, external to Siemens, Ingar Fredriksen from Elwatch. And today we're going to be talking about the power of wireless and the power of wireless IoT sensors. And I guess the benefits linked to a number of use cases, including predictive maintenance, but I'm sure we'll cover sort of a broader range of use cases as well. So I guess before we get started, if I just hand over to you, Ingar, just to introduce yourself and Elwatch as well to the audience, that'd be a really good starting point.
Yeah, thanks, Niall, and thanks for having me on the podcast. So quickly about Elwatch first. So we are a technology company from Norway that provides a wireless, online, and user-friendly sensor system, or in other words, an IoT sensor system. And we provide this mainly to industrial customers. And I'm the CEO at Elwatch. My background is electronic engineering. That's where I took my education. And I've been working with development of new technology and introducing it to various markets for more than 25 years.
Excellent. Yeah, welcome. Yeah, welcome to the podcast. And I should say, we'll go into this a little bit later in the conversation, but you actually know Senseye quite well as well. So we'll talk a little bit about that as well. But just to get take us back to the beginning, I guess. So a lot of people would have heard of wireless and wired sort of sensors, and maybe you're comparing the two, and they've compared the two in the past. So maybe we should start there. What are sort of the differences between the two, besides the obvious, but maybe some of the challenges and the benefits between each side?
Yeah, so wireless IoT sensors have many advantages, and the first I want to mention is rather obvious. It's the elimination of cables. So cable costs some money, but very often the installation cost is more complex and more expensive than the cables themselves. So that's really the number one benefit. It's very simple, but it's straightforward, but it's the number one benefit of wireless sensors. So, and in addition, there are applications where cables are simply not possible. It could be mobile equipment, or it could be in extreme environments that are caused by either high current, high voltage, high temperatures, or other reasons where you cannot fit a cable. So you need something that's wireless and disconnected from the rest of your system. And then traditional industrial sensors, which are cable, they need to be connected to a PLC, which is then connected to a SCADA network. And this requires multiple disciplines to be involved to get them operating. And that simplicity you get with IoT sensors is a big benefit with wireless IoT over cabled sensors. And yeah, finally, I just want to say that the flexibility of a wireless system is superior to any wired system. If you just compare them to mobile phones are way more flexible and provide a lot more opportunity than the old landline phones. And that's really a comparable situation with wireless sensors and cabled sensors in the industry.
It's interesting you sort of make that comparison as well. Unfortunately, I'm old enough to remember landline telephones as well. I'm showing my age a little bit. But when did that sort of change start to happen, away from... Because I'm guessing, or maybe presuming that wired solutions were the sort of traditional approach, but there must have been a sort of shift towards wireless and a focus towards that at some point. Maybe you could sort of comment on that a little bit?
Yeah, on phones, you mean?
Oh, no, on IoT sensors, yeah.
Well, wireless technology has existed for many, many years, but using it in bigger systems and connecting a lot of devices really came probably with the mobile phone. So there is a comparison there as well, where wireless technology was built to have networks that could cope with thousands and tens of thousands of units inside the same network. So the technology has been available to do things like IoT sensors for probably 20, 30 years. But then there are other bottlenecks other than the wireless communication and the networking. It's it has been difficult to make cost-effective IoT solutions or IoT sensors for industrial use because of battery technology, current consumption in sensor technology, stuff like that. So there's a lot of with the technology moving ahead, new possibilities occur, and now industrial IoT sensors are cost effective. You can get them to last for many years, and they're pretty much useful for the industry.
And I guess from your perspective, Ingar, when what sort of inspired you to sort of set up Elwatch? You say the technology was developing, there was a bigger demand for it, but why specifically were you sort of thinking in this area? And I guess with your wireless sensors, what's sort of the differentiation in the market?
Yeah, if time allows, let me tell you the story about how Elwatch was created. So,
Please
yeah,
do.
so we had an idea to create a solution that protected against fires starting in electrical installations. And we wanted to create a sensor that detected increased temperatures in these electrical installations, and not to detect a fire, but to detect issues that could evolve into a fire hazard or a fire. So to do that, we needed to create an IoT sensor because we needed something that could measure and communicate online and give alerts if there were increasing temperatures. And this is, by the way, also the reason we're named Elwatch. We wanted to watch over electrical installations. But the founders of Elwatch were way ahead of their time because they had these ideas back in early 2000. And this was before the invention of smartphones and app and cloud solutions. So the company actually had to hold back on that idea and didn't start developing it until, probably 8-10 years ago, we started developing IoT sensors for real. But the idea is more than 20 years old at this company.
No, it's interesting as well, because obviously myself being so engrossed in the world of predictive maintenance, and I've seen sort of a big shift in the past. I've been with Senseye now, Siemens, for over 3.5 years, and I've seen a shift there. But a lot of people I speak to on this podcast, for example, are always saying, "Oh, but predictive maintenance goes back many years as well." So it's not just the technology now; it's actually been something ahead of its time. Would you sort of, agree with that?
Yeah, and we see the same thing. My education is electronic engineering, so I never learned this at school. But I hear from people that know this that predictive maintenance as a concept has been around for many decades, probably since the Second World War. And my understanding of why this isn't widespread is the cost and complexity of it. Cost, I mentioned cables earlier. So cost of cables and getting this data up, the complexity and involving many disciplines to be able to set it up with data science. That was required because you didn't have softwares like Senseye that would analyze the data for you. Then being able to collect a lot of data without cables saves a lot of costs. So it's really the new technologies that have emerged with AI, with wireless technology, battery technology, really was needed to be able to get this out rolling in the market. I think that's the reason for predictive maintenance not being used more than it is until today.
And I guess another interesting aspect is something I've learned, talking to people in the industry at events, because there's a lot of talk about Industry 4.0 and stuff, but there's this idea that there's obviously a boom. You'd be able to know better than me, but a big boom in terms of we must collect data and use IoT, and then once the data is collected or started collecting data, it's then but we've collected all this data, but now what do we do with it on the other side? Is we've been told to do this as part of digitalization, and then is there some do you see that talking to customers? Are they clear at the use cases that can result from IoT?
Yeah, they're becoming clearer and clearer. I meet some organizations that have collected data for tens of years without really understanding what to do with it. But I think what I really see is that the reality, if you read about Industry 4.0 on the internet, you would think that the industry is very advanced. and how they do things. When you talk to industrial companies and see how they actually do it, that most of the companies are not at Industry 4.0 yet in most of their operation, and many companies with none of their operation. So the real world of industrial companies are really in a different world than what you read about on the internet about Industry 4.0. So it's still an emerging thing to be smart using new technology, collect data, and use data for something real. But I do see a trend that industrial companies now have very clear ideas on what they want to do. And no one really wants my sensors or Senseye software. They need solutions to their problems. And that's what we try to discuss with our customers as well. What problems do you have and how can we solve them? And sometimes the answer is not our sensors, but very often it is, unfortunately.
No, and you're right, because you could easily go into a conversation and start talking about Industry 4.0 and, maybe even Industry 5.0, which I did see at an event, must have been about 2 years ago, which did make me laugh because, I don't know, it's someone trying to push the conversation further. And what you're saying, Ingar, is companies aren't, they're not even ready for Industry 4.0 from what you're saying. So to talk about something further along the line seems...
I wouldn't say they're not ready for it. I would say they're not there yet. So they're developing, they're going into that. Yeah. They are ready for it, but they're not there yet.
Yeah. And so what's that gap for getting there, I guess, or what's the roadmap for that? Maybe it's different per customer, per industry, but is there any sort of thoughts in that area you can sort of provide?
Great question. So it's more about what are the barriers then, maybe that's maybe your question there. Yeah. And we think the barriers are very often people. So, and there could be people for several reasons. So first of all, there is a lack of knowledge on what possibilities IoT and any new technology can provide you. And without that knowledge, it's really hard to get started because you don't know where you're going on what's possible to do. And then there is a second barrier, which is also people, because there's often the lack of resources to install and reap the benefits of IoT sensors. And people exist in their organizations, but they are prioritized to do other tasks, like repairing equipment instead of fixing things for the longer run. And there could also be other barriers like cyber security concerns. We meet that a lot. People think that their cable sensors that they have in their automation system that's connected to nothing give a lot of benefits. But again, it's people that is the risk. On cybersecurity, it's really people that is the risk, right? So I don't think using a Senseye software or any other software or L-Watch IoT sensors or any other IoT sensor is the big security risk. It is how people use their logins, how they share their logins, their API keys. That's the risk for any cybersecurity attack.
Yeah.
And then this is maybe the biggest one, I think, for people or industries not getting started, is that in many organizations, management will demand return on investment, that this is documented before you do even the smallest investment. And our experience is that the best return on investments we see are calculated after installation and use. So neither we nor the customer could imagine the size of the positive effects that the solutions gave. So to conclude from that is that one must dare to make some small investments on new technology and then find methods and processes that give great financial benefits. You cannot always see it up front. You have to dare to try out something new and understand what it could give you.
No, exactly. And we'll talk a little bit more about return on investment in a second. I just wanted to touch on your point, you know, the importance of people, which is clear, because I think a lot of people sometimes think, oh, you could just deploy technology and IoT and don't really have to think about people. It's all about the technology. But we say all the time at Siemens and as part of the Senseye team, people are so key to this sort of transformation that sometimes in the predictive maintenance, well, we're sort of asking of our customers, or we're on the journey with our customers. But on the point of sort of knowledge and maybe lost knowledge as well, how do you see sort of generative AI and Copilot sort of filling in that, that gap where, people are leaving businesses, and you said there's not as many maintenance people or people with knowledge on the shop floor to deal with the issues. I mean, what role do you see them playing?
So how should I answer that? So I think a lot of knowledge that exists are at the industrial companies, are on their assets, on their processes, how they run their production line. They rely a lot on external consultants, on special knowledge, like it could be deep vibration analysis, for instance, used for maintenance, predictive maintenance, to be able to see if there is an issue up front. And this is where I believe technologies will help sort of get rid of some of those consultants, because it has to be made simple enough for the industrial customers to understand what the data we provide means, and so they can get actionable items. What should I do when this happens? And then, AI really has a role, but we also see how clear and obvious many data series are if you just collect them and look at them. The change in vibration, for instance, on electrical motor that has some kind of issue, it's very often so clear to see that at this date and time something happened and vibrations increased, current consumption increased, the surface temperature increased. So it's just about collecting the data, start looking at them, and then you can, when you have hundreds of assets that collect that kind of data, you need some software to help you identify where the changes are. But it's not always so difficult data sets that you need to analyze.
No.
And I think that's good. It's good for the Senseye software, it's good for Elwatch as the IoT supplier, but it's even more good for the industrial company, because their people will be able to detect that something is going on by simply collecting data and looking at it.
Yeah, and so maybe it's a good time to sort of bring those two together. So I mentioned at the start of the podcast that Senseye very well, and had a relationship pre-acquisition by Siemens, and we'll talk about how that's sort of evolving later as well. But maybe Ingar, you could give a bit of background on the story of the collaboration together. I know there's a couple of customers, at least, that you've collaborated on. So, just a bit of background, I guess, first of all, just to open it up a little bit.
Yeah, so maybe I can mention some of the industries where we work as well, and some we also do together with you at Senseye. So one of the places we started with our IoT sensor, I said we started with monitoring electrical installations, but that gave us an IoT platform. And then we started working with several companies in Norway and Sweden, both multinational large corporations and some small and medium-sized enterprises locally. And at that point, we were not selling a use case or a predictive maintenance. We were just showing off our IoT sensors. And what we discovered is that there was a lot of great ideas on how they could improve what they were doing at these industrial companies. But they didn't have the means to do it. It was too cumbersome and too expensive to do with cable sensors, reprogram PLCs, get IT involved to do things. So we started working with these companies, and with IoT sensors, we could help many of those good ideas to be tested. And it turned out some of these ideas were really good and gave a lot of value to our customers. So, and sawmills was one of the customers or customer groups that we work with. There's a lot of sawmills in Norway and Sweden. And they use our are sensors for predictive maintenance. The development of our vibration sensor came with in cooperation with sawmills. And that vibration sensor we started selling to more and more companies, both in Scandinavia and around Europe. And one of them was a primary aluminum producer that wanted our sensors for predictive maintenance. And after using us for a while, we discovered they had this great software for anomaly detection, which was Senseye. So that was a customer that independently chose to use both Senseye and L-Watch IoT sensors. Yeah. And we also have several customers in paper, pulp, cardboard manufacturing that also use both Senseye and L-Watch IoT sensors in conjunction. So that's how our cooperation with Senseye started.
Yeah, and is there a reason why, you mentioned sawmills and, paper, pulp and paper. Is there a particular reason, and you mentioned aluminium as well, but are there reasons why those particular industries sort of stood out, and became successful, successful deployments, let's say?
I think it's more a coincidence that we started in sawmills and more based on the fact that there's a lot of sawmills in Norway and Sweden than particular being more maintenance challenged than other industries. We try to look at this, what type of industries do we succeed with the most, but it's really hard to find a pattern. What we see as a pattern, though, is that there need to be people at those customers that want to make a change and have some curiosity to try out new things. That's a pattern. That's a clear pattern. But if they manufacture, if it's food manufacturing, if it's cardboard, if it's paper, if it's metal or mining, it doesn't matter that much.
And yeah, you talked about, and you mentioned earlier as well, actually, Ingar, about there has to be a willingness on the customer's part to be sort of open-minded, sort of new technology, new ways of working and stuff. Do you see that as a general barrier or quite an important barrier to sort of entry? And then maybe what other examples are sort of barriers to sort of implementing wireless systems and the wider IoT use cases, let's say?
Yeah, that openness to the future is something I think any company need to have, even if it's not related to maintenance or industrial companies at all. You need to be open to what does the future bring. So yes, we can see it affect our possibility to sell IoT sensors or software solutions into these industrial companies, but those kind of companies really have a problem, period. If you're not open to what's coming in the future, how can you improve what you're already doing? Even if you're making money today, maybe you may struggle in 10 years if you're not open to new ideas.
Yeah, I'm wondering, and to be honest, I guess that's not something now where we've got AI and new technologies, but that must have been an issue, throughout time. Let's say, even when you said in the early 2000s, again, it's contextual. Like now it will be about adopting AI and technologies to do that compared to, yeah.
I think there are several examples of great corporations that forgot to look forward and missed out on future opportunities. So Kodak is, of course, a very well-known example. When digital imaging came, they still believed in their old technology and probably died because of that. I told you I worked in the technology industry for more than 25 years. I worked closely with Nokia and BlackBerry, probably 15 to 20 years ago. And they were a great company with great products, but they both failed on some changes that happened in the mobile phone market with not adopting Android not adopting Android. That's probably their biggest mistake. BlackBerry didn't adopt capacitive touchscreens, so no one wanted their phones anymore.
Exactly. And you could, and in, like I said, relating it back to more industrial environments, maybe IoT, it's a similar thing where, you can keep ignoring the facts. But in the end, it could cost you in the long run, whether it's, being able to produce your products or whether it's, stoppages and the cost on that side. So there's definitely a comparison there to be made.
It is. And then I think companies like Elwatch and also Siemens with new innovative technologies, we should have respect for these industrial companies with hundreds of years of history. They have a very long horizon on what they do. So obviously they won't change everything they do overnight. It's maybe long processes to decide that, okay, we're going to change the way we do maintenance from what we decided in the 80s until what the future should bring. So we need to have some respect for that long horizon they have on their operation.
Exactly. And actually, I guess this might be a good time as well to talk about, the future, which we often do on this podcast as well. We often ask guests to look into their crystal balls a little bit, which can sometimes be difficult because we know technology can change so dramatically. But I guess specifically to IoT technology and wireless sensor development, where do you see sort of the next stage or the next phase for that sort of type of technology?
Yeah, so you know what they say, prediction is very difficult, especially if it's about the future. But I'll give it a shot anyway. So we already see a rapid increase in acceptance and integration of IoT in the industries we work with. So what this does when we work deeper with some specific industries like primary aluminum smelters, it helps identify new needs that in turn lead to development of new sensors targeted for those needs. And on the technology side, the future development of microcontrollers is important for IoT sensors. So microcontrollers are the small computers that is inside every sensor. If it's cabled or a wireless IoT, you always have a microcontroller. And these are becoming increasingly more powerful without increasing power consumption. And this enables more processing at the edge, either on a sensor or in a gateway. And in the future, I think you can imagine things like AI and machine learning running on industrial sensors itself. You don't always need to put it up in the cloud in the future. And then we believe in simplification. So this is a very strong trend. Technology is already much easier to use than it was a decade ago, and this must continue. So advances in technology that is usable without technological understanding is required to make it accessible and usable and profitable in most professions, in more professions, in all kinds of industries and services. And we had to, when you look at the industrial world today and compare it with our private environment. So after all, people are used to using smartphones and apps in their daily lives. And new generations, they expect software used at work have the same simplicity as what they're used with from home. So I think that trend will continue to make things simpler and more understandable and available for everyone. And then to talk about maintenance and trends within this space. So I think the way industrial maintenance is done will change. So IoT sensors make taking the step into predictive maintenance on all assets affordable. But for this to be a success, for predictive maintenance to be a success, the way industries work with maintenance also need to change. So take maintenance management software, also known as CMMS, and as an example. So many CMMS softwares can create work orders through APIs, meaning that another software such as Senseye or Elwatch IoT software could create many of the work orders. And we believe this is a major trend that dictates how future software is delivered. So not only to perform tasks within the boundaries of your own software, but also in interaction with other software resources and tools.
And that's an interesting, and you're right. And one thing, again, I've spoken to other people on this podcast about is it's not just one provider who can solve all of this. So, speaking, from a Siemens perspective, it's not like Siemens can solve everything. Elwatch can't solve everything, and others. So it's right. It's a team effort across industry, particularly when you're talking about sort of link it to sort of legacy systems as well, where customers have invested in legacy systems, have maybe data there. And what you want to do is not say, oh no, you need to reinvest in all this other stuff, but actually in some cases reuse a lot of existing investments, let's say.
Yeah, and I think that's what we're doing together as well with many customers, because when you deploy the Senseye software at industrial customers, you reuse a lot of the data they're already collecting. And in some cases, the customers identify, well, I need some more data points here. I need some vibration data that I don't have today, because I don't need that for automation, but for predictive maintenance, I need it. Maybe current consumption or other sensor data points that I don't have. And that's when they need IoT data to blend into that data and be used with one common software that can understand it all. So they are reusing what they have. It's not ripping out everything they have. It's about evolving what they have into something better.
Yeah, exactly. And I guess on that note, it's a nice segue into, we're talking about reusing existing data, and you've already been working with Senseye for a number of years, as you mentioned, and of course other partners as well. But the other reason why we're talking today is you're now part of the Siemens Accelerator marketplace as well. So maybe you could, Ingar, give a little bit of background into how that came about, why it came about, and sort of what opportunities you see for Elwatch by joining the Accelerator program.
Yeah, right now, Niall, I have to say it excites me a lot to be on the Siemens Accelerator webpage. We see it as such a recognition of our products and our team that Siemens wants to promote how well Elwatch IoT products integrate and completes various Siemens products, such as Senseye. So we really hope that will open up bigger markets for us. We have products. We already sell products across Europe and in North America, but we're a small company. We're not able to reach out to everyone. And getting on that Siemens Accelerator webpage, we hope that will give us a lot of new opportunities going forward.
Yeah, exactly. I don't think slightly biased being part of Siemens, but or a Siemens employee, but that's why I see the real benefit of Accelerator. It's not just for the big players, because you'd expect to see the Microsofts of this world and other big Accentures and other big players in the market. But it opens it up to companies of all sizes, including Elwatch, which have a lot of expertise, great products, a great team of people, and ultimately great service to customers. And that's sort of the beauty of the Accelerator. It's this open platform, collaborative across with different partners and stuff, and the knowledge from our perspective that Siemens isn't the one solution for all. That's what we're trying to do.
Yeah, and you mentioned Elwatch being a small company, but there's also a lot of small industrial companies out there that could benefit a lot from our solutions, if it's IoT sensors or if it's Senseye software. And the way of doing business today is not knocking on all doors and getting a local supplier to deal with everything. We help. I think the Siemens Accelerator page helps customers around the globe find great solutions that they can use in their operation.
Absolutely. And you're right, of course. Yeah, so it's not just the size of the actual partners on the marketplace, but it's the opportunities to serve customers of all sizes as well. Yeah. That's a really good point. So I guess we're coming towards the end now. It's again been really fascinating to dive into this topic. One we don't usually dive into too much, or haven't in the past, but it's been really fascinating for me. I guess just to sort of finish and sort of close things off, Ingar, it might be useful if a company's sort of looking at wireless sensors at the minute and thinking of either making that shift or adding it to their existing, collect more data points. What would you suggest as a starting point, beyond obviously talking to Elwatch, but in terms of what do they need to sort of think about and put in place in their own heads or think about first?
Yeah, I'll link it to our unique selling proposition though, because I think
That's all right.
I think I think that's what you should be looking for as well. So we when we promote ourselves, we talk about having robust sensors that are able to withstand industrial environments. You have to look for that. You don't have to use L-Watch, but you have to find someone that has sensors that can live in your environment. Wireless IoT sensors will be battery powered to avoid any power cables, and that means battery life can become an issue. And there's a lot of companies that say they have 10 years battery life, like we do, but you have to look at what you get with 10 years battery life. There are sensors out there that are being promoted. They claim 10 years battery life, but then they supply you with a few data points every day. So you need to make sure that you get the data you need and still have an acceptable lifetime of the battery. There are also solutions with replaceable and rechargeable batteries. And that sounds great, but can be very cumbersome in industrial installation, because if you have to take the sensor out of production, maybe need a production stop to get it removed and then recharge it or change the batteries, that will give you a lot of work. So finding something with batteries that stay there and live for 10 years is something you should aim at. And then what kind of sensors do you need? Because there are IoT sensor suppliers that have one or two sensors. There's a lot of companies that focus on vibration sensors only, but you may want temperature sensors, pressure sensors, water detectors, current measurements, all kinds of sensors. So look for if you're new at IoT sensors and are looking for a new supplier, find someone that has a wide portfolio. And the most important is you're not supposed to marry with this supplier. You're not going to be stuck with them forever. So find someone where you own the data. So if you buy an IoT sensor, you should demand that the data you collect is yours. You can use it whatever way you want. And it has to be simple to use that data. So open APIs that are documented, where you can collect the data and use it in any software, for instance, Senseye, but also any other software, CMMS software, any other software that you want to use the data. That has to be possible from the IoT sensor solution you choose. And yes, you get all of this with L-Watch.
Coincidentally. No, but in all seriousness, I think there's some really great sort of tips in there as well. I think one thing we didn't cover in detail is the battery, big battery operated, which has its challenges as well. But it's interesting how you mentioned some providers may get around that by only collecting a small number of data points, which may mean you don't collect the amount of data that you need for whatever your particular use case is. So that's why I think that was a really cool and interesting take on that as well, which was really cool. But
and it's different, right? If you want the outside temperature, collecting it once per hour is maybe good enough. But if you want something to detect that vibration is increasing on an asset or current consumption is increasing, you need to sample a lot more frequently to get it done. And we put a lot of efforts in researching how can we get enough useful data out and using as little energy as possible in the sensor. So and this is really a challenge in every choice we make when we design software and firmware and hardware on our solutions. So you have to ask yourself, what is the right choice here to get useful products and still consume as little energy as possible from the battery?
Yeah, it's a pretty careful balancing act, isn't it?
Yeah, it absolutely is. And there's always things that would be nice to do, maybe supporting some wireless standards that we don't, because it would require way too much of the energy from the battery if we were to support Wi-Fi and Bluetooth or LoRaWAN or NB-IoT directly from the sensor. So it doesn't work in an industrial setting. So you can never get everything, but that getting that balance right is really important to design a good IoT sensor solution.
Yeah, it's about knowing these different things to consider and then choosing what's best for you based on that information, I guess.
Yeah.
So just one more question, I guess, before we finish, Ingar. If people want to find out more about Elwatch and what you're doing and your products, where should they what channels should they visit?
So you can find a lot of information about both our product and a lot of applications or use cases on our website, so elwatch.com. It's very easy to find us through the Siemens Accelerator webpage. Just search for Elwatch on that page and we will pop up and you will read about us there, and you can also get links to our website and various stories about customers and use cases and even a video that's linked there.
Excellent. Fantastic. And actually, to make that easier, we'll put that in the show notes as well when we publish the episodes, so people have easy access to that as well. So I think that's all today. Again, really interesting conversation. So thank you, Ingar, for taking the time, take us through and your knowledge of the industry and your thoughts on a lot of different areas. Thank you for that. And thank you everyone out there for listening. And we'll see you on the next episode. Thank you very much.
Thank you.
Please like and subscribe on all major podcast channels and find out more about Senseye Predictive Maintenance at Siemens.com.